The new James Webb Space Telescope is having a revolutionary impact on the field of exoplanetary research, which is the study of worlds that orbit stars other than our own. Shortly, we will obtain our first insight into the circumstances that exist on rocky, potentially Earth-like worlds that exist outside our solar system. It's possible that life exists in one of these faraway worlds, but would we be able to recognize it? Let's find out more in today's video. Do you like space mysteries? Want to learn more about what the cosmos might be hiding? Tune in for more videos by clicking that subscribe button and hit the bell to get notified of our brand new updates. In the makeup of the atmosphere surrounding the planet, there might be traces of life that we can find. Transmission spectroscopy is a method that allows us to look for evidence of various gases in starlight as it travels through the atmosphere of a planet. This method works by separating light into its wavelengths, which allows us to do so. The presence of life on this planet may be indicated by certain gases that absorb starlight. These are referred to as biosignatures. Number 1. Oxygen and ozone. Oxygen is the most noticeable of all biosignatures. We breathe it in, plants produce it, and geological records show that the levels of it in the Earth's atmosphere altered considerably as the evolution of life progressed. The oxygen that humans breathe is O2, which is made up of two atoms of oxygen bonded together. However, the James Webb Space Telescope is also capable of observing O3, often known as ozone, which has a different signature than oxygen. So, if we found evidence of either of these gases, would that conclude the investigation? Sadly, this is not the case. A planet that is experiencing what is known as a runaway greenhouse effect is another situation that has the potential to produce massive levels of atmospheric oxygen. Once a planet has reached a temperature high enough for its water ocean to evaporate, the water vapor that is left behind in the atmosphere contributes to a greenhouse effect, which in turn leads to a feedback loop that further superheats the planet to temperatures that are incompatible with life. At some point in the future, the temperature of the planet will rise to the point where water molecules will be able to split apart into hydrogen and oxygen. Hydrogen molecules are light and can travel quickly enough to readily escape the planet's gravity. On the other hand, oxygen molecules tend to hang around, waiting to be discovered and fool unwary astronomers. Number 2. Phosphine and ammonia. Exoplanets may be taking up most of the attention in the hunt for life right now, but there have also been some discoveries made far closer to home. Recently, phosphine, a gas that is normally found in hydrogen-dominated atmospheres like those of gas giants like Saturn and Jupiter, was discovered in the atmosphere of Venus. Phosphine is a naturally occurring substance. Phosphine is an interesting candidate for a potential biosignature because of its structure. Microorganisms, such as those that live in the digestive system of animals, are responsible for the production of phosphine here on Earth. Because carbon dioxide is the predominant gas in the atmosphere of Venus-like planets, we would not anticipate finding significant amounts of phosphine there if life doesn't exist. Despite this, we are unable to discount the possibility that there are further sources of phosphine on Venus. Another potential biosignature gas is ammonia, which has a pungent odor and is likewise produced by creatures on Earth. As is the case with phosphine, it is found in abundance on gas giant planets, but it is not likely to be found on stony worlds where life does not exist. The presence of phosphine or ammonia in the atmosphere of a distant exoplanet, on the other hand, is likely to be difficult to detect. On Earth, the quantities of both of these substances are extremely low, amounting to barely a few parts per billion. Therefore, unless our possible extraterrestrials stink far more than creatures that live on Earth, we probably won't be able to find them anytime soon. Number 3. Methane plus carbon dioxide. There are very few individual gases that can be used as unambiguous biosignatures. Therefore, if we want to find life, it is probably best to hunt for a combination of gases that can do the job. Large quantities of methane, which is created by creatures on Earth by passing gas, in combination with large quantities of carbon dioxide, would be a good signal that something is going on. Instead of forming methane when there is an adequate supply of oxygen, carbon would much rather congregate with oxygen in the form of carbon dioxide, or CO2, which consists of 1 carbon atom and 2 oxygen atoms, or CH4, 1 carbon atom and 4 hydrogen atoms. Any carbon that finds itself in a methane molecule in an environment with a high concentration of oxygen will, almost immediately, exchange its hydrogen companions for a couple extra oxygens. Because of this, the presence of a significant amount of both methane and carbon dioxide together would indicate that something, possibly bacteria, is continuously creating methane. Number 4. Imbalances in the chemicals. We can apply the reasoning presented above to any other possible combination of gases that ought not to peacefully coexist. Because it relies on chemical reactions to produce energy, life disrupts the chemical equilibrium or balance of its surrounding environment. On Earth, oxygen is converted into carbon dioxide, but if life existed in a different kind of atmosphere and had access to a different set of molecules, it would employ alternative processes to do the same thing. For instance, methane-producing bacteria can extract chemical energy from minerals and other chemical components in their environment, which on Earth is in the deep waters of our planet. The practice of looking for imbalances enables us to maintain an open mind towards the potential nature of life in other places. What will happen if we find signs of life from another planet? The James Webb Space Telescope has already surpassed our expectations in terms of its ability to observe the atmospheres of exoplanets. Transmission spectroscopy is a powerful tool, yet it will still be difficult to use on rocky planets with mild temperatures and atmospheres that are dominated by nitrogen or carbon dioxide. This will be the case even if transmission spectroscopy is potent and available. The signals that we anticipate coming from these planets are going to be substantially weaker than the signals that we have successfully observed coming from the atmospheres of hot gas giants. If we are fortunate enough to observe starlight-absorbing gases in the atmospheres of a rocky exoplanet, such as TRAPPIST-1e, we will still need to estimate how much of these gases are present to arrive at significant conclusions. This is not a simple task because the signals can overlap, and they need to be properly separated from one another. Even if we were to find and precisely measure one of the possible biosignature gases, I do not believe that we could assert that we have found evidence of extraterrestrial life. The James Webb Space Telescope has just begun to open up a new and rich laboratory of planetary atmospheres, and as we continue to examine it, it is almost certain that we will discover that many of our earlier assumptions were incorrect. It would be hasty to assume that aliens are responsible for every strange occurrence just because we uncover something out of the ordinary. A finding of a biosignature by the James Webb Space Telescope would be an interesting lead that would promise much more study to be done in the future. Well, what do you think about this whole thing? Do you think it might be possible that aliens could be just around the corner? Let us know in the comments below, and don't forget to leave a like and subscribe to our channel.